Logistic regression. It's a mouthful, isn't it? But don't let the name scare you. It's a powerful tool used in many fields. We use it to predict things. We want to know if something will happen or not. Will it rain tomorrow? Will this medicine work? Logistic regression helps us answer these yes or no questions. It's like a detective looking for clues. It finds patterns in data. These patterns help us make predictions. It's a bit like figuring out if a cookie is homemade or from a store. You look at the shape, the size, and the sprinkles. These are your clues. Logistic regression does something similar, just with data. Now, you might be wondering where the name comes from. Why logistic regression? What does that even mean? Let's break it down and explore the fascinating history behind this powerful tool. The word logistic might seem strange at first, but it has a fascinating history. It comes from the Greek word logistikos. This word means skilled in calculating. It's also connected to the word logos, meaning reason or word. But the story doesn't end there. Logistic is also linked to the word logarithm. Logarithms are a powerful mathematical tool. They help us work with very large or very small numbers. You see, logistic regression uses a special S-shaped curve. This curve is based on logarithms. This curve, called the logistic function, is the heart of logistic regression. It takes data and transforms it into probabilities, but we'll delve deeper into that in a bit. For now, let's travel back in time to see how this statistical method came to be. The story of logistic regression begins in the 19th century. Scientists were studying how populations grow. They noticed something interesting. Populations don't grow at a constant rate. They start slow, then speed up, and eventually slow down again. This pattern looks like our S-shaped curve. One of these scientists was Pierre-François Verhulst. He developed a mathematical model to describe this growth. He called it the logistic function. This function later became the foundation of logistic regression. Over time, statisticians realized that this function could be used for more than just populations. They could use it to predict the probability of an event happening, and so, logistic regression was born. Let's take a closer look at the logistic function. Imagine a graph. On the x-axis, we have our data. This could be anything, like hours studied or rainfall. On the y-axis, we have the probability of something happening, like passing a test or a plant growing. The logistic function takes this data and draws a smooth S-shaped curve. This curve represents the probability of the event happening. At the bottom of the curve, the probability is low, near zero. At the top of the curve, the probability is high, close to 1. Let's say we're predicting whether a student will pass a test based on hours studied. If a student studies very little, their chances of passing are low. This would be at the bottom of the curve, but as they study more, their chances of passing increase. This is represented by the curve going up. Eventually, even with more studying, the probability of passing won't increase much more. This is the top of the curve. This S-shaped curve, the logistic function, is why we call it logistic regression. It's the key to understanding how this powerful tool helps us make sense of the world around us.